In this video, we'll take a look at the first method to solve an exponential equation, which would be an equation that contains an exponential function. So, for example, we want to solve 5 to the 3n equals 125. Solve for n. Now, the first way to go about these types of equations, if we can, is to use what's called the common base method. And the idea with that is that we know that exponential functions are one-to-one. Okay, so that means for every output, there's only one input. And what that would mean is if you have a to the b equals a to the c, okay, these would be the two outputs for our exponential function, and we're saying they're equal. Well, if they're equal, then the inputs had to be equal because of the one-to-one property. So if you can get a to the b equals a to the c, then you know that b must equal c. In other words, common base, answers being equal, the exponents must be equal as well. Okay, so 5 to the 3n equals 125. If I can get the two sides to have the same base, then I can set the exponents equal to each other. All right, so I need to know some powers of numbers to be able to do this. And 125 is 5 times 5 times 5. So I can rewrite 125 as 5 to the third power. Now I have a common base, right? Left side equals right side. The bases are equal. Therefore, the exponents must be equal. So my next line, I can write 3 to the n equals 3. And now I'm in a world that I'm used to being in, right? We just divide both sides by 3, and we get n equals 1. Let's look at two more examples. All right, so we have 32 to the 2x equals 8. As I look at this, I can't really think of how to get 32 as a power of 8, right? 8 to the first is 8, 8 squared is 64. That's not going to be helpful. So I got to think about other numbers that are raised to powers to get these two numbers here. Now, if we've played 2048 enough, we know that 8 is a power of 2, and we also know that 32 is a power of 2. So I can rewrite 32 as 2 to the 5th power, and 8 as 2 to the 3rd power. And as I do that, notice what I've done here. I've put the 32 as 2 to the 5th in parentheses, because that's still being raised to the 2x power. Over here we have 2 to the 3rd. All right, so I've almost got what I want. I've almost got equal bases. I first have to resolve this issue here with the power to a power rule. And the rule here is if I have a power to a power, then I multiply the exponents together. So the left side becomes 2 to the 10x. I now have equal bases. So something with the same base equals something with the same base. Therefore, the exponents must be equal. So I can set 10x equal to 3 and solve for x from there. Divide both sides by 10, and we will get x equals 3/10. So in this case, we need to change both of these numbers to have the same base. Again, I need to know something about powers. And we're not going to go crazy here, but we got to know, powers of 2, powers of 3, powers of 4, powers of 5, powers of 6. It's probably as high as we'll need to go. Maybe powers of 10. One more example. Has a little bit more going on here. So 1/6 to the power of 3a times 36 to the negative 3a equals 1 over 36. Again, we want to try to get a common base eventually. So we have a 6 here. 36 is 6 squared, so it's a good bet that we're going to use 6 as our base. No problem changing this to 6 squared. No problem changing this to 6 squared. 1/6, though, is interesting. And one thing we have to recall from past courses with our exponent rules is how to use a negative exponent. So if you recall, 1 over 6 is the same thing as 6 to the negative 1st power. Negative exponents tell us to write the answer as or write the base in the denominator with a positive exponent. So 6 to the minus 1 is the same as 1 over 6 to the 1st, which we see over here, 1 over 6 to the 1st. All right, again, we've got power to power to apply here and over here. And then we're going to have to do something with 1 over 6 squared to make it have a base of 6. So again, this is the negative exponent concept, 1 over 6 squared is going to be written as 6 to the minus 2. So in our next line, we apply power to power rule. 6 to the minus 1 to the 3a is 6 to the minus 3a. That's multiplying the exponents. 6 to the squared to the negative 3a is going to be 6 to the negative 6a, multiplying the exponents. And then we write 1 over 6 squared as 6 to the minus 2. All right, now I have 2 6's being multiplied. So same base, multiplication. The rule there from the other day in class is to add the exponents together. So now I'll have 6 to the negative 9a equals 6 to the minus 2. These expressions are equal. They have the same base. Therefore, their exponents have to be equal. So we're going to set negative 9a equal to negative 2. And from there, we solve a normal linear equation like we're used to. Divide both sides by negative 9. And we get our solution of a equals 2/9. So that's the common base property, way to solve exponential equations. This can't always be done. And when we get to a place where it can't be done, we'll have to look at a different technique.